Rakam, namaste, namaskar. Welcome back to Jal Prayag. It's been quite a while since I did my last video, and I'm going to continue on the same last topic which I took, which was regarding the day's work. And today I'm going to start looking actually in the day's work concept, because till now what we did was trying to solve the basic questions of parallel sailing and a plain sailing, which is eventually used in the day's work question. So I'm going to start this module will be only talking about the concept. That means, why am I doing a day's work question? So what is the reason I'm doing it, and what purpose, what do I achieve by doing a day's work problem? So that is what I'm going to do in this particular module today. And in the next module, I'll do a problem. So that way you understand why I'm doing it and how I'm doing it also. Okay. Now, a vessel can sail various combination of courses and distance in a given day, and a day as far as a day's work is concerned is starting from like today's noon to tomorrow's noon, and that is only on the ship's local time. Okay. Now, this whole day's work question will use plain sailing formula, and of course, it will be involving the modified parallel sailing formula also. And if you look at the general majority of the ships, I'm not talking about high speed vessels, maybe a big container vessel, which is doing quite a lot nowadays. I'm talking about a normal vessel where, let us say, it's around 12 to 15 knots for each hour. So, in that case, we normally will not cross 600 nautical miles in a day. And so, that is the reason we can use plain sailing concept. Okay. But you should be prepared. In exams, they can always give you a question which involves larger distance than 600 miles. This should be carefully examined. I will talk about this, the next concept called Mercator sailing in the later on videos. You have to figure it out and then solve a Mercator sailing. So right now we're not doing it. Let us look into the concept and, like as I said, why and how. That is what I'm going to. Let me just quickly give you a small example of a global aspect of sailing. Let us say I'm traveling. I want to start from a position called Alpha, which is approximately somewhere here, and I need to go to Bravo. If I just ask you what is the global direction of these two waypoints A and B, it's very easy. All I need to do is join from A to B, and this is the direction, general direction or global direction I'll be going. And this can be given to you in a different format, which you already done as DLAT and DLONG. So this clearly tells me that I'm going northwesterly. Okay. Now, if someone gives you a departure port and an arrival port Alpha and Bravo, you cannot sail directly. You cannot do this. So you might have to follow various courses. And I'm just giving you for the sake of example. Okay. This is the global direction, which is in the violet color. But what happens to the local? You will see the vessel might sail like this, then like this, like this, like this, like this, and finally reach the destination. This is this is a generic concept to show you what is the difference between global and local directions. I'm going to show you one more picture. Uh, Let us say I will take it in a day. So I'm going to give you with times. I'm going to show you what can happen to you in a day, alone in a day. So let us say I start from here noon, because I said day's work starts from one day noon to the next day noon. So I'm starting at alpha, which is 1200 hours, let us say today. So I might be sailing like this up till 1600 hours. Then I might go like this till 2000. Then maybe like this for 23 until 0300 next day morning, and then till noon on the next day. So this is what is a day's work. What I've just done is a day's work. You can see I've done various courses for different durations also. So how to solve these kind of problems, that is what we are going to see, and that is what is day's work. Now, for me to do or solve this problem, I'm going to break these small legs, which I have already shown you, into small right angle triangles. So the moment I put right angle triangles, I can use the three formulas of plane sailing method which you have done. I'm going to just recap on that. And then, of course, I have to use modified parallel sailing formula. Why? Because that is a relation between departure and D long. So I need to do that. So let us see how these various legs, which I showed you just on the previous slide, how I'm going to make it into various triangles, right angle triangles. Before that, a quick recap. This was the quadrantal system we saw. We have four quadrants. Theta cannot be more than 90 degrees. And please remember, angles are always measured first from north or south, and then only you should go east and west. So this has been already discussed in depth. And the three sides of the triangle are distance, delat, and departure. And then we have a quadrantal course. These are the four formulas. The first three formulas directly relate to the triangle. And the fourth formula is the relation between departure and D long alone. We have done examples also, so I'm not going to spend time on this. Let us go to this particular day's work concept, what we are doing. This is exactly what I had drawn on the slide, two slides before. Now I'm going to break them into pieces into right angle triangles. How do I do it? You will see on the first leg, which is from A to B, I have something called southerly component, which is your delat. Then I have an easterly component called departure. And the direct course was your distance, direct just A to B. And the course, as I said, should be always measured from south, and then I should go east. So this is the course. So I have resolved first leg into a right angle triangle. Now, what about the second one? Delat, departure, and the course. The third one, please remember, has got only delat. There's nothing called departure. There is no easterly, westerly. The fourth one has got a southerly component, then a westerly component. Then after 3 o'clock till noon, I have a very long easterly component, which is departure, and then the northerly component called delat. And again, I have a distance and a course. So this is what I have done in a day's work. I have broken them into pieces, into different right angle triangles for each leg. So this is the concept of your whole day's work. And this is what you do. But then how do I complete the question? What I do is I calculate departure and delat for each of the triangle, then find the resultant delat and resultant departure. When I'm doing resultant, I can also find a resultant distance and a resultant course. So let us quickly look at that. The resultant distance is called distance made good in a day, and resultant course is called course made good in a day. The same triangle, same course what I've done. If you join A to B directly, that is what is called distance made good in a day. Now, this distance made good also has got a resultant delat and a resultant departure. So this is the resultant delat and this is the resultant departure. And I have a resultant course also. And this is what is called course made good. So end of the day, in all your day's work question, you will be trying to find DMG, CMG, and that is what is your whole idea for your day's work. And how do you get this resultant? You normally form a small table. So when you form a small table, you can write individual delat and departures and find the resultant. And this resultant delat and departure, when you apply it to initial noon position, you can get the next day's noon position. Okay. Now, in addition to finding this, as I said, we have to find your DMG also, which is your resultant, and your CMG also. Okay. So normally, what are the type of questions they can come? They will ask you the next day noon's position. They will ask you distance made good, and they will ask you course made. Okay, various conditions can be imposed on this, and various data can be given to you to solve the problem. That I'll talk about that later. But in the next module, what I'm going to do is I'm going to talk about a simple day's work question. So that is what I'm going to do in the next module. This module is over. The idea was to just tell you how to start off a question and what is the basis and the reason and the concept. Okay, so please keep watching Jal Prayag. I'll come back soon with a question, and then we can see what are the different cases, and we can work that out also. Till then, Vanakkam, Namaste, Namaskar.